we create, for example, the shape of a car, or let's have any shape like this one, okay? For example, have this shape, okay? And you fill it this shape by the color. So I've seen it for filling, we have seen for the moment just filling by the color. But we can fill with a gradient fill, we can also fill with a texture. So this is what we'll see in the next class, inshallah. But for the moment, we created shape and we want to fill this shape with the color. And then I want to see just one part of the shape. For example, here I have an oval. And I want to see only the part of the shape that is inside this oval. So this will be done by using the clipping. So I'm clipping my shape by using the second shape here. So the clipping shape here is the oval. Okay, so you can do this for any type of shape. Okay, you can display an image and then you can clip an image by the text, for example. Or here you can just using here a clipping shape of this rectangle, so you'll see only this part of the image. Okay, we will see also how to create text. Okay, and then we'll see how to convert this text to shape. So from the text we can here get the outline of the text, and we can make a shape by using this outline of the shape. And once we convert the text to shape, then we can do the same thing. We can using this text to clip the image or to clip the shape that we have. So this is basically what we see in today's class. Okay, so the objectives are to deal with the clipping shapes. So here we have anything in our view, and then we can use any shape to clip what we have. So if I use this triangle, I will see only the part of the shape that is inside this triangle. Anything outside the triangle will be, you cannot see it, will be masked. Okay, so the clipping area here is this triangle. Okay, so we'll see also how to handle the text in Java. So how to make the properties of the text, how to select how to set the properties of the text, how to get the information from the text, and how to use these information. And we'll see also how to convert this text to shape. And once we convert the text to shape, we can use this shape to make also clipping area. Okay, so here we see some complex operation on text rendering. So let's start with the clipping. Okay, so here what do you have? We have here hello. Principally, we have hello. Okay, and then I want to see only this part of hello. So I can select here this clipping area. So if I apply this clipping area, I will see only this part of the message or this part of the image. So the rendered image here may be clipped by a clipping path. So here we are using this clipping path. The clipping path defines a region in which the object will actually be visible. So inside, this is the pen instead of the highlighter. So inside this part, you can see what you have. But outside this part, you cannot see anything. So everything here will be masked. You cannot see it. Okay. So when an object is drawn, it is clipped against the clipping region. So portion of the object filling outside the clipping path will not be drawn. So anything outside the path will be masked. Okay. And any shape object can be used for clipping. So if you have anything that is object type, that is shape type, you can use it for clipping. Okay, that's why at the end of this course, we'll see how to convert the text to shape. And once we convert the text to shape, we can make a clipping by using the text itself. So here we have an example. So this method can be handled repeatedly to clip the current clipping region further in the specified shape. So let's see this program. So here what we have. Okay, now let's focus on the first line. So this is the line that we are using for clipping. So here we are clipping what? We are clipping G2. So here we have G2.clip. So to make a clip, so here we have to use G2.clip. And then here we have to give a shape. if we are using this shape for clipping G2. Okay, so what is this shape here? Now in this example, we are using just an ellipse starting. So here the upper left corner is 0, 0, and here we have 200 as width and 100 as the height. So I'm using this ellipse to make clipping. Clipping what? We can clip anything. So we can return back to the previous example. So the previous class where we created an object like this. So we can, for example, use this ellipse like this to clip this the shape that we have. So the clipping shape will be here, the ellipse. So what can you see here? You will see what do we have inside the ellipse, and what do we have outside the ellipse will be masked. You cannot see it. Okay, so let's do this together. So here we are using this ellipse for making the clipping. So let's copy this text and let's return back to the previous example. So we don't need this. Maybe this text we don't need it. Okay, so in the previous class, we created this general path, okay, and then we filled this general path. Okay, so let's see. Okay, so this is the general path that you have seen in the previous class. Now let's suppose that I want to see just one part of this general path. Let's suppose that I will have to create an ellipse like this, and I want to see only the part that is inside this ellipse. So how can I do this? I have just to create the ellipse, and then I can use g2.clip. Then I can clip the image. Okay. So this is our general path. Okay. Now I have to use the clip. So here g2.clip, and we are using this ellipse for making the clip. Okay. Now, first of all, the clip should be before the filling. So here I'm clipping, I'm selecting the clip shape, and then we are filling the path that we have. Okay. So what can you see here? So you can see here that we have already our general path. And also, so this is the general path that we have. And here we are using this ellipse as clipping area. Okay. So now we are applying. So let's do it without the clipping, and then let's see the clipping effect. Okay. Now without clipping, what can you see? You can see that we have the general path. This is the general path. Now let's apply now the clipping. Now you can see that you are using this ellipse to clip the general path. You can change the dimensions of the ellipse. Let's make it, for example, 150. Let's make it 500. So you can see now that we have another part. So you are taking another part of the general path. Okay. So we can start from 0, 0, and we can make it as 400, and 200. So this is the clipping ellipse. So you can see that now we are taking another part of the general path, but now the clipping ellipse is almost this one. Okay. So are just displaying the part that is inside this ellipse. Is this clear? How to clip a shape by using a clipping shape. So our shape here is the general path, and we are clipping the general path by using this shape, which is an ellipse. Any question about this? No questions. So we have done with the general path. Now let's remove the general clipping, and now let's see what you have in this part. So here we are just creating, or we are just drawing many lines by using a lookup. So let's see what we have. We have for I equals to 0, I less than this dot get bound dot get width. So here we are talking about what? So this. So here we are in the paint component. Here we are in this panel. So when we run, here we have a panel. And what is the dimension of the panel? We have 640 as a width, and we have 480 as a height. Okay. So when we run, you will see the window in which you can see the graph. So this window has a dimension. Okay. So the dimension here is 640 by, we will use it 480. Okay. Now the idea is that you want to draw some lines like this. Okay, so what is the coordinate of the first point? So let's suppose that I want to make this line. And I need, for example, between the lines 5 pixels. So what is the coordinate of this line? So to create this line, we need this point, and we need also this point. What is the coordinate of the first point? So for the x here, we have 5, and for the y, we have 0. And this is the first point. And the second point, this point here, for the x, we have here 5. And for the y, we have here the width or the height of the window, which is 480. And then we can make, this is P2. And then we can create a line between P1 and P2. This will create the first line. And then how to create the second line? We have to do the same thing, but here instead of 5, I have here 10. Okay, so here for the x component, we have 10, 0. And then for the second point here, we can have 10, 480, etc. So here, this will fill the panel that you have with parallel vertical lines. Okay. So this is what are we doing in this example. We have for int I equals to 0, I less than, so this, which is the panel, get bound, and from the bound you are taking the width. What is the width of the panel here? This dot get, or bounds dot get width. What is the width of our panel here? I've seen that the width is 640. So this value here, we can replace it by 640. And then I plus equals to 5, so our increment here is 5. And then we are drawing a line between I, 0. So at the beginning, I is 0. So the first point will be 0, 0. This is the first point. And then the second point will be I, comma, this dot get bound dot get height. What is the height? I've seen that the height is 480. And the first point will have the coordinate 0, 0, and then 0, 400. This will be the first line. And then I will be incremented. We will add 5. Then we'll draw the second line. So the second line will be here for the x component, which is 5, 0. And then for this point, it is 5, 480, etc. So then we continue doing this till the value of I equals to 640. Okay, so let's see this without applying the clip. Let's remove the general path. We don't need it. Now you can see that we fill it the screen with lines, and between the lines you have a space of 5. You can change the space, you can make it 10. It's okay. Any question about this? Now, we have this, now our view has many lines, but I want to clip these lines by using an ellipse, or by using a rectangle, or by using a path. Okay. So here to do this, we can use g2.clip. And then what are we doing for the clip? We are using here this ellipse. Okay. Now let's run. Yeah, what's the problem here? Why I cannot see the clipping effect? Let's focus on the program. Why I cannot
clip before?
Very good, very good. So the clip should be before drawing the lines. I have to set the clipping shape, and then we can display the different lines. Now you can see the lines, but they are clipped by the ellipse. It's clear? Can change here the line. You can make the distance of 3, for example. You can see the effect. So here we are clipping the image by using this ellipse. Clear? Okay, now I have already a path. Can I use this path to clip the lines that you have here? What do you have to change to set the path that you have created as a clipping shape? So instead of using here the clipping shape as an ellipse, you can use here the general path. So I can use the general path, which is the GP, as a clipping shape. So let's use the g2.clip and then the general path. So now we are clipping G2 by using the general path. And then you can draw anything, and anything here drawn or drawn will be clipped by using the general path. See the effect? So you can see that now we have the lines, and the lines, they are clipped by the general path that we used. Is clear? Okay. You can use as clipping area rectangle, you can use oval, you can use any shape. Okay, let's continue. So I have done this slide. So here, as I explained, we are using here g2.clip to make the clipping, and the shape that we are using is this shape, which is this ellipse. And then we are drawing the line, and when you draw the line will be clipped by using this shape. Now let's see how to create text and how to display text, and finally how to change this text to a shape. So in computer graphics, the text processing is special type. So the text represents here a special type of geometric object. So the text here is an object, okay? And we can extract shape from this object. So a text string can be compactly represented by a sequence of characters. So when we say that we have a string, it is a string of character, okay? And here we are using to display this character, we are using the standard coding scheme like the ASCII or the Unicode, okay? So the actual rendering shape of the character are determined by predefined fonts. So here we have predefined fonts, like here, these fonts. So these, they are called logical fonts, like serif, sans serif, the monospacer, dialog equal. So these, they are called logical fonts. And for every font here, you have a style. So the font can be plain, can be italic, can be bold. And for every font, also we have a size. So you can select any size as an integer. You can use 8, 10, 100, etc. You can select any size. Now, to create a font, we need three things. We need the type of the font, the name of the font, we need the style, and we need the size. Okay, so the actual, the geometry describing the shape of the character is known as a glyph. So here we see also how to extract the glyph of the character. So let's suppose that we have a text. So this is an example of text, which is TEXT. Okay, so the shape of this text here, shape that you have here, and the text itself can be converted to shape. So this shape here, it is called the glyph. Okay, so we see how to convert this text to shape. And once we convert the text to shape, we can do anything with this shape. We can draw the shape, we can fill the shape, we can use the shape as a clipping area, etc. So the Java 2D offers a rich set of font and text manipulation features. Okay, so the most common high-level usage of text involves creating a font object and calling the method setFont and drawString in Graphics 2. So generally, if you want to display any text, you want to display a message. Okay, so before doing this, first of all, you have to define the font that you want to use for this message. Okay, and we can do this by using the setFont. Once we have done with the setFont here, so first of all, you have to create a font, and in this font, you have to give the font name, which is one of these string, and then you have to give the style. Is it plain? For example, font.plain, font.italic or bold, etc. And then you have to give the size. So first of all, you have to create a font. Then you have to use the method setFont to apply this font, for example, g2.setFont, and then you give the name of your font. Once we have done with the font, then we can draw the string. We can give the string that you want to draw. In this example, our string is the word message. Okay, and then you have to give where to put the string, so the X and the Y components. So this is how to create text or how to display text in Java. So the font object can be selected in Graphic 2D with the method setFont. So first we have to create the font, and then you have to apply this font by using the setFont method, and then you can draw the string. So let's suppose that I want to draw the string hello in EE201. So, okay, so after preparing the font here, I have to use the draw string, yani g2 dot draw string, and then here you have to make the message. So the message, for example, hello in, for example, Tm240. And then I have to give the X component and the Y component where I want to place this message in the script. Let's make, for example, 100, 100. This will display the message hello in Tm240 at this coordinate. So here we have the screen, we have here 100, and then here we have 100. So at this location, text will be displayed. Okay. Any question about this? Okay, so in addition to applying existing font, it is also possible to derive a new font. Okay, let's try this before deriving a new font. Let's see how to create, first of all, a font and how to draw a string by using this font. Okay. Okay, let's create a font. For example, no font. Now, let's use, for example, serif, sans serif. So first of all, here we have to create a new font. Okay, so we have to use font, and then I have to give the name equals new font. Font is used, for example, F equals new font. And then I have to give the options of the font. So what are the options? I have to give the name, I have to give the type, and I have to give the size. Okay, so let's use here, for example, serif as a name. Let's use now the type. So for the type here, I have to use font dot. And then you can see that here you can use italic, you can use plain, you can use, so let's use italic, okay? And then I have to give an integer. This integer is giving the size. Let's make it as 100. Now we created a font, okay? Now we have to apply this font to G2. So we can make G2 dot set font. And here I have to use the font F that we created. So now we created the font and we selected this font in our graphics 2D G2. Now we can draw the string. So if you want to draw a string, you have to use the method draw string. And you are drawing a string in G2, so we can make G2 dot draw string. And then here I have to give the string. Let's make the string, for example, hello or welcome to Tm240. And then let's give here 50 for the X component and 50 for the Y component. So the string here will be drawn by using this font. Okay. Let's remove the clipping and let's change the color. Now G2 dot set color. And let's use, for example, green. So I can see that now we have the text, welcome in 240. Let's remove the line without anything. Okay, let's make the text here. Starting from 100. See the effect. So you can see that now what we did, we drawn the message welcome in Tm240 by using this font, which is the serif, and here we use the italic and the size 50. You can change the italic, you can make it as bold, for example, and you can change the size, you can make it as 80, and you can select string. You can change the position where to place your message. You can make it as, for example, 200, 200. Any question about this? No questions. Very good. Now, once we have done with the string, we can change this, or once we have done with the font, we can apply some changes to this font. Okay, we can change the type, we can change the size, we can apply the geometric transformation that we have seen in the previous class. We can apply them also on the font. Okay. Now, in addition to applying existing font in the system, it is also possible to derive new font from the existing font. So I can create a font and then I can create, or I can derive a new font from the existing font by modifying some attributes. So I can use, for example, derive font, and then I can change the style, I can change the size, I can change the style and the size. I can apply and find transform TX I can change the style and apply at the same time and apply. Okay. So in addition to changing the options or applying some modification on the text, we can also take some measurement from the text. Okay, and these they are called font metrics. So the font metrics, they are measurement of the rendered text. So first of all, you have text, and then we are rendering this text. And from the rendered text, we can take some metrics. Okay, so here, first of all, we have to have a font, and then we have a text, and then we have to render this text. Once we render the text, we can check or we can take the metrics of this text. Okay, so the following methods of font provide the font metrics information. So here we use two methods. We use the get string bound and we use the get line metrics. So the get string bound will give us a rectangle. So the output will be a rectangle. And this will be the rectangle containing the string. Okay, so here the inputs are the string that we need and the font render context. And how to create the font render context? Here we have the function get font render context to extract the render context. And you can also the get line matrix. So what are the lines? Okay, so here for any text we have different line. I added this image to the slides. So if you have a message like this one, okay, so you can see that here the maximum line here, it is called the ascent line. Okay, this line here that you have here, it is called the baseline. The minimum line here, it is called the descent line. Okay, and here between the two lines, we have what we call the leading. Okay, and the height of the line will be from this line to this line. So these some information that you can extract from the text or the font render context. Okay, so we can extract also the rectangle holding the message, or we can extract the different line by using the line matrix. And once we have the information about the line matrix, we can draw these line matrix. So the next example, you will see an example program in which you are drawing this rectangle and you are drawing also these line matrix. So to do this, first of all, we have to extract this font render context. So how to extract this? By using the method get font render context. Okay, so the get font render context will give us the font render context. Okay, then here we have to use one of the two methods. We can use the get string bound, and the output will be rectangle, or get line matrix, and the output here will be the line matrix. Okay, so the get string bound method will return a bounding rectangle for the string. For example, here our string is hello. This will, the output will be the bounding rectangle of this string, which is this rectangle. The get line matrix will return a line matrix object that contains more detail about our text. Okay, for example, it will give us the baseline. So here it will give us the coordinate of the baseline, which is this line. It will give us the ascent line, which is this line. It will give us the descent line, which is this line. And it will give us also the leading, which is the extra space between the two lines. This is the okay, so the following method can be used to retrieve the matrix. Okay, so here we can use the get ascent to find the ascent coordinate. Get descent to find the descent coordinate, and you can use the get leading method to find the leading coordinate. So you have an example. So I have font. Let's use highlighter. We have font. So this font here is the name. Okay. Here we have the name of our font. We call the new font. So the type is using the same serif, and it is bold. And this is the size, which is 36. And then we are creating an affine transform. So affine transform Tx equals to affine transform. And this transform is shearing transform. We are using a shearing over the x-axis by a factor of 0.5. Okay. Now I want to apply this transform to the font that we created. Okay. So to do this, I have to use the derived font. So here g2.set font and then font.derived font. What is font.derived font? So font.derived font will create a derived font to here. And we are setting this font to G2. So the new font here will be the first font, but here we are applying a shearing of 0.5 over the x-axis. Okay, and then we are drawing the string derived font at the position 100, 100. So here you can see that at the position 100, 100, we have here derived font. You can see that here we have the shearing effect. Okay, you can see that we have the shearing effect of 0.5 over the x-axis. Is this clear for the first part? Okay, so now we return back to the first font that we created here. So g2.set font, we are using the same font that we used initially, not the derived font. And then we want to extract some information about this font. So we can extract what? We can extract here the bounding rectangle, and we can extract the information about these lines. Okay. Now to do this, we have to extract this information by using the method get font or get font render context. So font render context frc equals g2.get font render context. So here we are extracting the font render context. After extracting the font render context, we can use the method get string bound or get the matrix. Okay. Now let's use let's have a string str equals string bound. So this is the string that we want to display. We want to display this message, which means string bound. And then we are creating a rectangle 2D, which is, and this rectangle will be get string bound of what? Of the string that you have here. What is the string? The string is this one, this message. And by using this font render context. So the string is this string, and we are using now this font render context. Okay, so here we created the rectangle, so we made the modeling, and now we have to show this rectangle. So we can use now g2.draw bounds. So this will draw this rectangle without the string. And here we use g2.translate 100, 200. So here our origin now is 100 over the x-axis and 200 over the y-axis. So it's like having now a new origin. Okay. So after drawing the rectangle, we can draw the string. So g2.string or g2.draw string. So this is how to draw the string. We have to give the string, and then we have to give the position. So here the position is 0, 0. Okay, let's check this step by step. Okay, we created a font. It is a new font. This is our new font. We applied now this transformation to get this the font. And then we have g2.draw string derived font. So here for the first part, see the first part. You can see that here we have the derived font. Okay, so if we display the string by using the original font, Now to G2 dot set font, and then our font here is font. So this is the original font. Now we are drawing the string now derived as font. You can see now the difference. So this is the original font, and this is the font after applying. We can display the two message. G2.translate. So over the x-axis, let's make it the same. Over the y-axis, let's make it 150. And then we are applying now the new font. And we are displaying this message, for example, original font. So now what do we have? We created the font, and the font name is new font. And we created an affine transform, which is a sharing over the x-axis with a factor of 0.5. And then here we use the font, the original font, here font. And then here we are drawing the string original font. Then we made a translate of 0.50, and then we change it now the font, which is now the derived font, by applying the TX transform, which is a sharing over the x-axis with a factor of 0.5, and then here we have derived font. Now we see the two messages, one with the original font. So this is the original font, and here we have the derived font. Any question about this? Okay, let's continue. Now we are returning back to the original font. So no need for this. Now I'm returning back to the original font, which is here original font. Now we are extracting the font random context by using the get font random context. And then we have our message here, which is the string bound. And we are creating the rectangle bound. And here we are using the method get string bound to extract the bound of what? Of this message by using the font random context of our font. Okay, and then we have G2.translate 100 to 100, and then we are drawing the box. Let's draw this part. So now you can see that you have the bounding rectangle of the message. You can see that you have only the bounding. Now we can display the string within it. Okay. So here G2.drawString, and then we are displaying the string, which is this one, string bounds, and the position will be 0, C. So we can say that now have the bounding rectangle, and you have the string within it. Any question about the bounding rectangle? Okay, so now we see the line matrix. Okay, so now let's change the string. Now we have our string is this message, and then we are making translating over the y-axis with the factor of 100, and then now we are getting the string bound. So in W, which is here we are making casting to integer font.getString bound. And from the string bound, we are getting just the width. Here we are taking the width of the bounds. And then we are extracting the line matrix. So line matrix lm equals font.get line matrix of the string, which is this string. And then we are using this font and the context. Now we are drawing a line from 0, 0 till w, comma 0. So w here is the width. Okay. And then here we have int y equals minus int ln.get ascent. So here we are extracting the information about what? About the ascent line, about the descent line, and then for the leading here we are using the descent plus the leading, and we are drawing these lines here. Okay, and we are also drawing the string. So let's run this. Now are in the complete program. Let's change the color. Let's make it as red. So now you can see that we have the different lines. Let's compare. So we have the first line here, which is the ascent line. Here we have the baseline. Here we have the descent line. And here we have the lead. So here we draw 4 lines. 1, 2, 3, and 4. Any question about this? Okay, let's continue. Now, in this example, we see how to extract the ligature of text. So the ligature here is the form of the text, of the geometry of the text, of the outline of the text. So glyph of character in a font can be retrieved as a shape object. So here you can extract the glyph, which is the outline of the text, and you can convert it to shape. And once we have a shape, we can use this shape to treat anything. Okay, this enables sophisticated processing and application of the glyph to achieve a variety of visual effects. So the glyph may contain multiple letters. Here, for example, we have a glyph with multiple letters connected together. Okay, so a common ligature. So we can get the geometry of the text by using this program. Okay, so first of all, we can create a new font. So we are using serif bold with a size of 144. We are extracting the font render context by using the method get font render context. And then here we are creating a glyph vector. So in order to extract the shape, first of all, we have to create the glyph vector. So glyph vector gv equals font dot create a glyph vector. So this method permits us to create a glyph vector. Okay. So now we have the information about the shape. Okay, so the shape, what will be the shape here? The shape will be this glyph vector dot get outline, meaning the outline of this glyph vector. So this will give us the outline here as the shape. And once we have the shape, we can do anything with this shape. Because initially here, the text that we use it is a string, it is a text. We cannot deal with it as a shape. But once we extracted the glyph vector and we converted this glyph vector to shape, and this shape is the outline of our glyph vector, then we can do or we can perform anything with this shape. Once we have the shape, we can use this shape to do anything. Okay. Let's see this example. Now we are creating new font, which is serif font. Okay, we extracted the font from the context and we created the glyph vector. So glyph vector gv equals font.create glyph vector of the font render context with text Java. So the text that we are using here is the text Java. Okay, and we have to convert this glyph vector to shape. We are getting the outline of the glyph vector. So the shape glyph equals gv dot get outline. And here we are leaving the information 100 and 200, which is the position where to place our text. Okay, so here you have 100 over the X component and 200 over the Y components. Okay, now what are we doing here in this example? We are using g2.setClip glyph. So that means we are using now this or the outline of the text as clipping shape. So we are using the outline of the text as a clipping shape. So g2.setClip glyph. And then here we have done with the glyph. Now we are checking or we are changing the color. And then in this loop here, what are we doing? We have here for int I equals 0, I less than 2000, I plus plus. And here we are creating some ellipses. So the shape equals the new ellipse b dot double. And we are using here random values times 100, random values times 400. So here we are talking about the X and Y component, where to place this ellipse, and the size of the ellipse are 30 and 20. So we are creating here some ellipses in random values. Okay, and you are drawing this shape. And here, when you draw the shape, you will see the shape, and this shape will be here clipped by the text that we use, which is the glyph. So you see this. Okay, first of all, let's draw the shape without clipping, okay, to understand what is going on, okay? So what we did here, we created many ovals. We created 2000 ovals. The X and Y component, they are random values times here 500 and 400. We can use here the length of the shape, which is 640, and then we can make it as 480 for the Y component. So you can see that here we have these ovals. You can change the dimension of the oval. You can make them as, for example, 10, T. And you can see the results. So here, how many ellipses we created? We created here 2000 ellipses. Okay. Now I want to clip this ellipse by using what? By using the text. So what is the text? The text is Java. Okay, so we can make it, for example, welcome to Tm240. And this text will be displayed by using the serif font, and it is bold by using this size. And we are extracting the glyph vector, and from the glyph vector, we are taking the outline of the glyph vector as a shape. And we are using this shape, which is a glyph, as clipping area. So now we are applying the clipping area. So g2.glyph.clip or g2.setClip, and we are using this glyph, which is this shape here. Now we can run. Let's return back to the original size. And we can run. You can see that now we have welcome. So here we can change the size and make it as 30 or 50. So welcome to Tm240. We can increase the number of ellipses. Make them as 5,000. Check the effects. So you can see that now we have welcome to Tm240. And here we use this message to clip the area. So you can see that now we have the text and the font of the text here. What do you have here? inside the text here you have just here the different ellipses. And you are displaying the text by using these ellipses. Any question about this? More questions? Let's see, Java. Let's have here a bigger size to see the effect. Okay, let's see the next example. So in the next example here, we have the first part, which is creating the font and then extracting the font from the context and then extracting the glyph vector. And finally, you are taking the outline of the glyph vector as a shape. So this part here will be for extracting or for converting the text to shape. And then we are applying this shape as clipping shape. And then here, what are we doing? We are creating, we have a for loop for I from 0 till I less than this dot width bound get width. So here the width that we have seen previously, which is 640. And then I plus equals to 5. And then we are drawing the line. So this will draw the different line that we have seen previously. Okay. And then we are clipping this line by using the outline of the text. So you can see this. Now let's see what do we have before the clip. So before the clip, we are just drawing the different lines. Okay, now we apply the clip, and the clip shape, the clipping shape will be Java by using this font. Now we can run. You can see that we have here Java, and the text Java is clipping the different lines that we created. You can make more line here. Choose for example. Let's see that now we have more lines, and we are clipping these lines by using the text. Any question about this? No questions. Okay, so I have done for today's class. In the next class, inshallah, we'll see the area, and we see how to fill this area by color. We have seen how to fill this area by